Finished, Grace? You got the right answer?
No.
True, we don't know if it's right. Let's do it so. Okay, so for A1 here, you have an ice skater of mass 85 kilograms. And then we have another ice skater of mass 65 kilograms. The speed here is 3.5 meters per second, and the speed here is 1.4 meters per second. And then they combine and move off together romantically. So, how fast is that? So the before momentum, M1 U1 plus M2 minus, right, Grace? What? No, beforehand they're going in opposite. Oh my goodness, how embarrassing for me, did I misread it? As I was saying, 65 times 1.4, we'll just fix that there. Nobody saw anything, this is not recording. And then they move off together. So afterwards their combined mass is 85 plus 65, and their combined velocity, we'll just call it v. Yeah, so let's calculate it. 85 times 3.5 plus 65 times 1.4 divided by 85 plus 65. Oops. What did you get? 2.5. Correct. V is 2.59 meters per second. So that's a good question to get started in the exam. You should have 3 marks here. Okay, let's have a look at A2 now. If you don't remember the formulas, they might be in the book for you. These formulas are not, though. Do you remember them? No. I'll write them down for you. Would you remember? No. Brass is just a type of material. Young's modulus is stress over strain. Does that look familiar? Stress, does anyone remember stress?
Yes.
Right.
Yeah, what is it?
Young's modulus is field.
Huh? No, materials. Stress, does anyone remember? Is force over area. Oh, this needs revision, I think. And strain, does anyone remember? No. Extension over original length. Okay. I'm putting a big mark here. When you go home, you need to do some revision here on this topic. Okay? Try it. Now that you have the formulas, you might be able to do it.
But there's some formula not in here we should be
difficult like that.
How did they choose this formula? Where is the formula book in which
I don't know. It starts off with no formula book, and then they started adding formulas, and bit by bit they add more. So I think it's just a case of maybe somebody said, hey, this formula's not in the book, we'll add it next year. So the formula book only gets bigger each year, not smaller, which is good. So your book might have more in it than this book. But you can't take any chances. Area. Time to do it, maybe? You know you have an exam in 2 weeks, yeah?
I can't eat, I can't sleep, and have a bloody nose.
Really?
So,
Exams make people feel this way. Yes. Sophie is sick, you're sick. After the exam you will feel better.
much better.
Much better, yes.
Or in high school, final exam,
Yes.
in high school, and I feel very sick.
Just relax.
And my mom gives me pressure, but you should go to the NCUK. Why you can't go to NCUK?
Just listen to your father.
My dad is keep saying the same words that you say.
What's the same words?
NCUK is better.
What is it of really?
Cork.
About the China University?
No.
UCC China. Okay, let's have a look.
It's college.
Yeah, University College of China, no? This is not one. Okay, let's have a look here. Right, I'll do this one now. Yep. So, A2. A brass wire of length 2.65 and diameter. Okay, so this is 2.65 meters. And the diameter is 0.765 millimeters. And then what happens is you have a weight here, pulling down on it of 8.5 G. And you're also told that Young's modulus is 1.11 times 10 to the 11 pascals. And the question is, what is the extension? So, let's look at our formulas. Are you ready? Can we look? Yeah? Young's modulus. No, hurry, look!
I just
Alright, fine, you don't look. You two look. Stress over strain. Do we know Young's modulus? Yes. Now, the formula for stress is force over area. Right? Do we know the force?
Yes.
Do we know the area?
Yes.
Yeah, here's the areas here. And the strain is the extension, which is what we want, over the natural length. So if you put in all the numbers, you get 1.11 times 10 to the 11 equals 8.5 times 9.81 all over extension 2.65, and the area is pi or squared, and that is 0.765 over 2 10 minus 3. Why minus 3 there? It's millimeters. It's a big fraction, but we can solve it for this part is what we want.
Before I get a final answer,
Yes.
can I tell an answer?
You can tell me before I say it.
Yes. Is it 4.33 times 10 to the power of negative 10?
That sounds too small, I'm afraid. It could be.
I have the English problem.
What's your English problem?
Reading the question.
That is a problem.
But if it's G constant G, it's wrong.
G is 9.81.
Just in the calculator there's another G. Same one.
I have no idea what that G is. I don't know what it is.
Yeah, that's
The same thing.
Is it?
Yeah, but just more decimal places.
Great. Now don't confuse me. Right, let's see where I'm at. So I did a little so I have 611.85 equals 1 over delta x over 2.65. So bring that up. So I get delta x equals 0.433, which is it, Harry. So the answer is delta x. No, I made a mistake. That's way too big. Sorry. Yeah, it should be a small number, not 43 centimeters. Right. 1.11 times 10 power 11 times pi divided by 8.5 divided by 9.81 times 0.765 over 2 times 10 to the power of minus 3. Yeah. Uh-oh. It is 2.65, isn't it? Eek. So delta x over 2.65. Oh no. 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 This is wrong. That's wrong. The 611.85 is over on this side. That's better. Delta x equals 4.33 times 10 to the minus 3 meters. So delta x is 4.33 millimeters. There we're talking. I don't know. Well, I had to do it.
Yeah.
I had to do it twice. It's a bit messy trying to solve this here for delta x. Don't try to do it in one step on the calculator. It's a mess.
But I did this time, this time what I did, maybe what I did is wrong. But the bottom number 2.65, I typed it with the numbers above the fraction.
Which numbers?
The 8.5 times 9.81 and the
Times
area.
2.65.
Yeah.
Yeah.
Times 2.65, and I got that, and then I just
Divided by
took
the
that number
area.
and divided by the Young formula.
What about your area?
I mean, I took the 8.5 and the 9.81 over the pi r squared, and I times it by 2.65, and then I just divided it by 1.11 times 10 power to the fifth.
What answer did you get?
4.33 times 10 to the power of negative 10 meters.
something went wrong with your powers. I feel like maybe typing in your Young's modulus division. You have the right numbers, but the wrong power.
I'll just check it.
Yeah. Great. Grace got the same answer, so it must be right. It has to be right. If I got the right answer eventually, and Grace got the right answer, then it has to be right. Okay, can we do the next part? Can we do the next part? Yeah. So the next part is they want you to draw a graph where you put load here, and that can be in newtons, and then you have extension here, which is in meters. So what's the relationship between the weight and the extension? What type of graph do you get?
Exponential.
No,
Just
not quite curved. It's a straight.
But isn't that a point when it just snaps?
There is a snapping point, yeah. So it continues straight, and then at one point then it breaks, and then it changes. But the question only wants you to draw up until it breaks. Then you can stop the graph.
So just like this.
Yes, just like this.
And it's 3 marks.
I know, I'm surprised too. So when you have no weight on the mass, then you have no extension. Yeah? It's okay? It's linear here. This is called the elastic region. And do you remember what it's called when it curves?
Inelastic.
Do you know what? No, it's not called that. It should be called that. Do you remember in class we said it's not called that? It's called plastic. Do you remember that? Yeah. Do you need to go to immigration? You want to go now? What time is your appointment at? 11:50 or 15? You better get going, because if there's a problem with the traffic, you don't want to be late. Yeah. You'll have to wait a year before you can go to GNIB again. Yeah, we continue then? Okay. The next one is what type? What's next? That one will be a little better, right? You were good at electricity, I think. You were.
I'm not good at it.
I don't think so. What? You can't say that when you get an A in the exam.
I get
So this one is G in the exam, G in the calculator.
In the exam, they usually use this one.
No.
Yeah, just stick with this one.
Yeah.
But for the other constants, you can use the
Can I
calculator.
use it assessment, my assessment, Newton assessment?
Yes,
Yeah, that's fine.
but that's
Yeah,
right.
thank you.
What's wrong?
breakfast.
What's breakfast?
Yeah.
Said you didn't like bread. You confused me.
I don't like bread. Home mom I find bread.
She makes you eat bread.
Yeah.
Life is difficult. Is it nice bread?
Chocolate.
That's delicious. No, thank you.
Question. Were there more questions in each of the questions? Because it's like A series A.
No, it's weird. It's not. It's like that.
It's
Yeah.
just it.
Yeah.
That's what happened.
Huh?
No, nothing.
You can watch the video later.
Are you
Go this way.
recording?
Everything is being recorded.
Please upload.
I will. I uploaded yesterday. Nobody goes to my YouTube channel.
I went
I want to watch.
Do you?
Yeah.
No, for some reason I rewatched the videos, but it's still no views.
Yeah, it makes me sad. It's uploaded.
Yesterday I watched the the final topic,
Yeah.
the final, there are two people with,
Two views?
yeah,
One.
Wait, is it physics or maths?
physics,
Oh, two people,
yeah,
including you?
not including me.
Ah, so one of them was you. Who was the other one?
I have no idea.
Maybe Amanda.
It's me.
Yeah.
And I see the photon video from last year,
Yeah.
and the voice is strange.
Yeah.
It's not sounds like Stephen.
Was this the class with Fahad?
And it's not with my head.
Hmm.
But it sounds like
Pakistan. Yeah. Yeah, maybe I was angry in that class with them. Maybe this is what happened. Anyways, I upload the photon one today.
Yeah.
Okay. Well, I see you after GNIB, yeah?
Yeah, yeah.
Okay. Good luck. You need it. Yeah? Be strong.
You're not Chinese. Bye-bye.
Shay. Right. Okay, try number 3, so.
Michael is 10 to the power of negative 6, right?
How are we doing with this? Is it okay?
Yes.
Okay, let's have a look at it. Well, I have the first part there. Did you get this for the total capacitance? Hareen? Andy? Did you get this?
Yeah. Yeah.
Are you sure? You don't sound sure. You're sure?
I times 10 and answer times 10 to the power of negative.
Okay, grand, okay. Now, it says an 18 is connected in parallel with the 6. So what happens here is you have a 12, a 6, a 3, a 12, a 6, a 3, and an 18 which is connected in parallel with the 6. So here's an 18. So how do those two add together? What do you have in the middle now?
6 and 8 you have to add it.
You just add them straight, don't you? So this is 24, isn't it?
Yeah.
Yeah? So now what's the total? We'll add them up. 1 over 12 plus 1 over 24 plus 1 over 3. So you get the total capacitance is 24 over 11 microfarads. Yeah?
I can't understand this question.
What happens here, Andy, is they add an 18 to the 6.
Not only 18, it's 12, 6, 3.
Yeah, the 12 and the 3 are still there. Well, actually, no, sorry, Andy. Yeah, because in the next part it says the total for all 4. Yeah. Did you just do these 2? Yeah, I understand. The other 2 are still there.
Yeah, I was quite confused with that as well.
But your English is good, no?
But it's like, if that means like these 2 are like very, like separate wavelengths, so like maybe they added the.
I know, but the question in the same part 2 says determine the total energy stored on all 4.
So 3 and another 4.
3 and 1. So when they say all 4, they mean this.
Wait, and then they
Leave
gave
me alone.
They gave us like extra information so we do nothing with that.
I'm not finished yet. Now, what they want. So next, right. So I have it simplified to just one capacitor. Okay. So we have 2.1818 microfarads. Yes? Now, what's the formula for the energy here? Do you remember? It's a half CV squared. Do you know the C? And do we know the V? So the energy is 1.75 millijoules. Look, this is the total, simplified into just one capacitor. The energy here is the same as here, which is the same as here. So the total energy here is this, 1.75 millijoules. Yeah? You don't look happy.
You don't have to care about the micro.
You could leave it as 1.75 times 10 to the minus 3 joules if you want. Is this what you mean? Or no?
We calculate with the micro.
Oh yes. You must use the micro in the calculation. Yes, 10 to the minus 6. Yeah.
English is
It's not too bad, is it? What EAT grade do you need?
I need a C.
That's okay, isn't it? What do you need, Sophie? C. And Harlan? That's not too bad, is it?
I couldn't because I couldn't.
Practice. Okay, let's have a look at the next one. A4 is also electricity.
the internal resistance is the constant resistance, right?
It's a constant, yeah.
That means like even in our lab report, we have like 1/, resistance is this one, right? The internal resistance.
No.
Is that right?
Yes.
I just no, man, I'll ask you. I'll see about your report.
Later. Sounds better.
So the EMF is the internal resistance.
No.
Why does it say EMF is the internal resistance?
Is it? Where's it set up? No, there's a comma. They're saying EMF is E,
Oh.
internal resistance is R.
I knew that.
Yeah, you know.
English.
Ah.
Have they ever asked like similar question that they asked before in the past year?
Mhm. Okay, are you ready to see it? How'd you do? Good? Yeah, it's been a while since we did this one, internal resistance. So what you have is a 5 ohm resistor, and it's connected across a cell of current. So you have here a cell. So I'll draw it in a picture like this, and its EMF is unknown, and there's a small internal resistance here, but we can measure the current. So we know that the current is 0.36 amps. Okay? Now, in blue, well, actually, before I continue, let me just write down the equation here. What rule can I use here? Well, before I even do that, is this picture okay? Can we just read it together and then look at the picture, okay? A 5 ohm resistor is connected across a cell and a current of 0.36 amps flows through the cell. Okay, can you look at my picture? Can you see how the sentence matches the picture? I don't know, because I look at your faces sometimes and I don't know if you understand or if you're just sleepy. This is the focusing face, so it means you understand, yes? Okay, good. Now, what rule could we use here to make an equation?
Kirchhoff.
Kirchhoff, which Kirchhoff? Loop or junction?
Loop.
Correct. Where will I start?
Start at the E.
E. So, go for it, Hareen. We start off with E.
E minus 0.3655 ohm.
Oh, and I skipped something. E minus 0.36 or.
Oh, yes.
Yes, minus 0.365.
Wait, but
What?
isn't the R 5 ohm?
Well, let's start this again. E, yes, minus 0.36 or.
But the R is given as 5 ohm.
No, it's not. This is 5 ohms. This we don't know. Here is E. Then I'm here. Now I'm here.
Okay. Minus 5.
3, 6 equals 0.
Oh, okay, yeah.
So we get E minus 0.364 equals 1.8.
Then another.
Yeah, now we need to make another equation. So, what they say in the story is, when you connect in parallel, a 4 here, what happens to the current? It increases to 0.485 amps. Yeah? So, we should put these two together. 1 over 5 plus 1 over 4. And then invert it. So together it's actually 2.22. So we can have now E minus 0.485 or minus 0.485 2.22 equals 0. We do the loop again. So I can make another equation. E minus 0.485 or equals 1.0778.
Oh, and this part, can we just use the calculator to find R and the...
You can use it to check your answer, and if you're running out of time, you could, but I don't recommend. Yeah, but definitely check your answer. Right, so I'll be lazy because I'm tired. So when I solve this, I get E equals 4.08 volts, and or, no, that's wrong. I must have typed it in wrong. 1 minus, no. Okay, it's just bigger than I thought. $6.34 seems very big. 1 over 4 plus 1 over 5. Yeah. Okay. The numbers are bigger than I would have guessed. But oh well, that's the answer. Do you remember doing this?
Yeah.
So, there are two parts in the question.
Yeah, the story, they give you two pieces of information. They tell you the current when it's 5, and then they tell you the current when it's an extra 4. Yeah. Wait, I'm trying to figure out if it's her focusing face or confused face. I don't know. Confused. Okay, what's confusing?
Because number 1 is you have to get R, little r, and then...
Yeah. For these questions, it's easier for me to do, like I know it says 2 parts, but really it's only 1 part. They want you to solve this and to get 2 answers. So you get the answers together.
doesn't matter.
No, I think in the exam I'll just write it like this. This is answer for part 1 and this is answer for part 2. But really, the question maybe should have said, find E and or for 5 marks. That's how I understood it. Okay, how are we doing? I think maybe we'll leave it there. Now, is it too much for me to think that you can do some of these at home because you have your lab report tomorrow? So am I wasting my breath if I ask you to try some at home, or?
Can try tomorrow after.
So the answer is yes, I'm wasting my breath. Okay.
No, we can answer tomorrow because we don't have class tomorrow, so we can do it for Wednesday.
Oh, that's right, we don't have class tomorrow, so you can do it after the lab report on Wednesday. Do you want to try and finish section A, and then when you come to class I can just do the rest of it in the class then, and then we can go back to taking turns in section B. Does that sound okay? Yeah. Also, some point next week I'll give you the September